మేడం నా వాయిస్ వస్తుందా మేడం? ఓకే మేడం.
హలో
వినయ్ వినిపిస్తుందా?
నీది వినపడుతుంది మేడం రావడం
మేడం వస్తుంది, నాకు వస్తుంది వాయిస్.
ఒక్క చూస్తాను.
హలో వినయ్ మేడం, వినయ్ లేడా మేడం?
హలో, వాటికి వాయిస్ వినపడుతుందా?
ఉందా వాయిస్?
ఓకే సార్.
ఓకే రైట్.
ఓకే ఓకే.
రెండు దాంట్లో జాయిన్ అయినావు చూడు, ఒకటి తీసేయ్.
అది తీయ సార్ ఫస్ట్ ఇది పెట్టేస్తా.
సరే, రెండు దాంట్లో తీసేయ్. నీరజ్
నేను క్లోజ్
క్లోజ్ చేయి, ఒకటి క్లోజ్ చేయి, క్రోమ్ లో క్లోజ్ చేసే. ఇప్పుడు ఓకేనా వాయిస్ అంతా?
Audible, sir.
సునీత మేడం,
Is it audible, sir? Everything is clear.
Sunita madam, we have brought some technical issues there. That's why I'm asking.
హలో
Madam,
వినిపిస్తుంది కదమ్మా?
okay madam, anda okay madam.
మేడం అన్మ్యూట్ చేయండి మేడం మీది.
హలో రాజాదాస్ సార్. హలో
Sir, your voice not audible, sir.
సార్, గుడ్ ఆఫ్టర్నూన్ సార్. సార్ రాజాదాస్ సార్, గుడ్ ఆఫ్టర్నూన్ సార్. సార్, is it audible?
Good afternoon, madam. Audible, madam. I'm audible.
ఆడిబుల్
Sir,
సార్.
is it audible sir? Yes sir.
Yes,
Yeah.
madam. Yes, madam.
Audible sir.
Okay, okay, okay.
Hello. Is it audible sir?
ఆడిబుల్.
Hello. Hello.
మేడం కంటిన్యూ చేయండి మేడం.
Hello.
Is it audible, madam?
Hello. Is it audible?
Madam, everything is clear, madam. Okay.
Hello.
Audible, madam.
Audible, sir? Okay, sir.
Audible,
Okay,
madam.
sir. Yes, some internet problem is, sir. This is not clear. So shall we start, sir? Hello, Rajendra, sir?
Yes madam, start madam.
Okay, sir. So good afternoon to one and all. I welcome all the participants to the second day of this one-week virtual international workshop on new advances in mathematical and computational sciences. Dr. Rajendra, sir, I welcome you, sir, for the second day of the workshop.
Thank you ma'am.
Welcome all the participants to the second day of. Now I would like to introduce today's speaker, Dr. Rajendra, sir.
సార్ అన్ని రన్నింగ్ అన్ని అయిపోతున్నాయి యూట్యూబ్ లో కూడా ఆడ చూసి 94 ఉంటారు 94 మంది.
Now I would like to
లైవ్ వస్తుంది చూడండి.
introduce today's speaker, Dr. Rajendra, sir, by Dr. M. Sridhar Babu, sir.
సార్ మీకు లింక్ పెడతా చూడండి, అదే లైవ్.
Good afternoon. Dr. Rajendra, Assistant Professor, Department of Mathematics, with Vellore. Sir completed MSc NIT
sir, మీకు
and PhD from Sambalpur University. Sir. Sir has 26 years of teaching experience. Sir has published more than 42 research papers in national and international journals. He authored one
దీనికి
book,
దానికి 60 seconds 30 seconds డిలే.
Handbook of
Okay.
Research on Computation Process Modeling and Optimization
Wrong, sir.
Strategy by IGI Global. And 11 book chapters in Springer.
ఇంట్లో సెట్టింగ్స్ అన్ని మారిపోయినాయి సార్. అప్పుడు యూట్యూబ్ చూసి కుట్టాడు వెబెక్స్ లో.
As of now, he has supervised 3 PhDs and supervising 5. He has attended
Pakistan
and gave lectures in several workshops, FPPs and conferences.
నీకే తెలుసా?
Sir received 2 awards. One is Best Teacher Award by PIET Odisha and another Teachers Award per year by WIT Vellore. Now I request you, sir, to start your lecture.
Okay, thank you. Thank you all members of organizing committee for giving opportunity to give talk on applications of mathematics on deep learning. So first I'll share my So today topic is applications of mathematics in deep learning. So the new term everybody knows that is deep learning. Now everyone is running after this deep learning. Recently, you might have heard that Google has developed one convolutional neural network, that is deep neural network. Through that network, they can take the image of retina of your eye, and they can say about your condition of your heart. So that means now everyone is working on deep learning. Now you take any stream, electrical, electronics, biotechnology, everyone started working on deep learning. So then this particular term deep learning is related to computer science. Then what we'll do? We are mathematicians. That I'm going to show you behind this deep learning, all are you will find mathematics. So now we'll see how you can relate, how you can apply mathematics in deep learning, how they have developed by using concept of mathematics. So I'm going to give you the idea about it, and very simple example I'll give you so that you can get it also. And so many research work are going on this topic. So in which area you can do the work also, that also I'll tell you. So what are the topics I'll be covering? Subtopics, that is introduction to deep learning, then artificial neural network with linear regressions, because in this particular topic, what we know from the beginning means lower classes already we have learned linear regression, how it is related to artificial neural network, that also I'll be showing you. The third one is feed forward neural network with back propagation, how we are using calculus for designing neural network. Then the fourth one, the last one, that is convolutional neural network. General, now everyone is running after this convolutional neural network because now the data is very high, right? It means huge data, we are dealing with huge data. If you go for the share markets, so that's a huge data. Every day we'll have so many data they are generating, and how you can handle, how can you predict, so how you can forecast. So that I'll be giving idea about it. So then we'll start with deep learning, how it is related. So deep learning is subset of machine learning, and machine learning is subset of artificial intelligence. So then artificial intelligence, that everybody knows, right? If you say artificial intelligence, that means suppose if I give any problem to you, so immediately you start solving according to your knowledge. That means you start exercising your brain, then trying to apply whatever you know, and you will get the solution. So this is called your intelligence, right? So how you can make artificial intelligence? So that can be done by using some rules you can write, or you can search in different way. Rules mean, suppose if I give some conditions, if according to these conditions, this is the solutions. So that means you are giving rules to the system. So according to the system, according to the rules, the system will find out the solution. Okay. And second one is you can search in different way. Like suppose one puzzle I have given. So there are different pieces, and if you keep in order, that will give a particular image. So in this case, what we'll be doing, you will go for the permutations. So different way will arrange, and if it matches with the given image, then we'll say that is the image, and you will solve the problem. So that is searching. Okay, we have learned in graph theory, right? Searching concept, depth for search. Okay, breadth for search. There are different search method are available. So we are applying. Okay, see, this is one kind of. Another one is you have data. So from the data, the machine will get learn. Then basing on that, he will identify whether that particular image is this particular person or not. This image is for that particular person or not. This is another way. So one is learning, another we are going for the searching, another we are going for the rules. So we can give the intelligence to the system in different ways. Now we'll come down. Machine learning. Machine learning means we have to learn the machine. So learning process can be done in many ways. So external data is there. We have to use different methods to learn the machine so that machine can solve the problems. That is called machine learning. Then what is the meaning of deep learning? Then deep learning is, then you have a neural network. That means how, suppose I'm giving one problem to you and you started working on it. That means your neurons in your brain start working on it and giving the solution Similarly, we'll design one artificial neural network like your human brain, right? And solve the problem and getting the answers. So when we'll increase that network, so that will be taken as deep neural network. So I'll show the diagram so you will be comfortable. So in those cases, we are also learning. So that kind of learning will say deep learning. So we'll discuss one by one. So this is about your deep learning, machine learning, and artificial intelligence. Okay. So next one is that all. I told that we are designing one network structure like human brain, right? Because human brain, in human brain, the neurons are connected to each other, right? Because we'll not discuss much about the biological concept. I'll be giving idea about the artificial neural network. So, but that is the artificial neural network is just like your human biological neural network, you can say. So in this case, what it is happening? So all the neurons are connected to each other and having some weights. Whenever we'll be giving inputs, so it will be multiplied by the weights and taking the summations. Just you get it, then we'll discuss deeply. So then summation, then some function will be given. So according to the function, it will fire, it will give the some values. Again, it will move in the forward directions. So that is the way it will be calculated and taking the summation and applying the function. Again, it will be coming output. So the main task in this case is what is that we have data. Data means we are having the input values, input parameter values and output parameter values. So the deciding of the weights, because every time we will be multiplying with the weights, this is connected. These two neurons are connected through weights. So that weight will be multiplied. So when we are multiplying the weights, that means what is the values of this weight? So that we have to decide. Okay. So main task in this neural network is how to find out the weights of the network so that error will be less. Error means suppose actual output is there, our model is predicting some values, the difference will be the error. So we want to minimize the error. We have to develop, we have to find out weights of the network so that error will be minimum. So that is coming under your deep learning. So we'll be learning how to do that one, that already I discussed. Now we'll discuss a single neuron, how it works. Then only you can understand, because I have shown the whole neural network structure, how it works. Now we'll move on to the, okay. Now we'll come to the neuron. Why I have taken as artificial neuron? Because it's a artificial, because it is not a biological neuron, right? It's artificial neuron. How we'll be designing this single neuron? The very simple concept. That means these are my inputs and these are the weights. That is Wn. Over here is n. Huh? This is your n. Huh? That is n. W1, W2, W3 up to Wn. So then this is a bias, right? W0. And this input is always 1. So 1 into W0. So then how it will be working? So you have to, whatever the input comes over here, it will be multiplied with corresponding weights, and adding will take the summations. Then according to the function can be written anything. According to this function, it will fire or it will return the values over here. The thing is, suppose I have 4 inputs and 1 output. So I can design the single neuron also. but it may work or may not work. Because you may not get the values of W so that you will get the minimum error. Suppose you have 50 data, sum of the error must be minimum. So you have to take the sum of the square of the errors, because sometimes you may get a negative error, sometimes you get positive error. So if you take the summation of error, then you may get less, but actually that is a maximum error is there. Okay, so now we'll come to the point. This is our single neuron. Very simple. You see, we are talking of artificial neural network, but it is a very simple task. Okay. Now, already I have written, there are n plus 1 neuron I have written over here. Why? Because we have taken, this is also one of the input, but that input is fixed, that is 1. So it will be multiplied 1 into W0. But in other cases, whatever the input parameter values, it will be taken. Okay. So basing on that, it will return the values. So that I have already explained. For x0, we have taken 1, already I told, and this is called also bias, right? And that weight we are assigning as W0. And sometimes you will be finding, if you refer some books, it will be B also they have written. So actually we have x1 to xn, that is actual inputs. Suppose any experiment you are doing, you have some input parameters and output parameters. So in this case, we have x1 to xn. There are n number of inputs. Then already I told how it works. Single neuron, how it works. You are multiplying with W1, and this will be also multiplying with W like this. Corresponding weights will be multiplied with corresponding inputs. So then we are taking the summations, and according to the function we'll write. And this function is called transfer functions, because you are returning according to the function, right? Sometimes it will be taken as an activation function. Okay. So now, so then I have again simplified. You can see in the previous case, you just go back. I have taken n number of inputs. This is a single neuron, but I have taken n number of inputs. To understand the exact concept of neuron, how we can find out the W and B, we'll discuss also. So I have taken one input, one output. So in that case, we'll take single weight and we'll multiply that one, and we'll be adding the B. I told instead of writing W0 also, we can write B. So, and this input is always 1. So that means Wx plus B, and whatever the function it is given, accordingly we'll find out. So that is about your single neuron with single input. So I have shown with whatever I explained. So that has been written over here. So for a given artificial neuron, let there be 2 inputs with signal x0, x1. So this is x0 and this is x1. So x0 already I told that always it will be 1 into B, and this is the actual input. So accordingly we'll, but the thing is how to find out W and B. That is the main thing. So that will get the minimum error. Sum of the square of the error will be minimum. So that is our aim. So main thing is over here is how to find out W and B, because you don't have any control on data. Data you will be collecting from external, right? So that data may be distributed anyways. You cannot say that it is distributed in this way, so that's why I cannot fit a function. Okay, that's why we are running after this artificial neural network, or you can say deep learning. Sometimes in which way we are fitting a function. Okay, what method you know, so may not be working. So then I'll show you which method already we have learned in lower classes that everybody knows. That is linear regression by the method of least square. But I'll be correlating with this single neuron. Now you have seen this is given in the artificial neural network, and this is the description of single neuron with single input. So what I want to say over here, what we are doing before, same thing they are representing in the network structure that I wanted to show you. That's why I have given this example. We know, everybody knows about it, but my aim is to so that this linear regression, what we have learned before, they are representing in the neural network structure. How it will be given in that form, that I'm showing you. So first, what I assumed, I took y equals to alpha plus beta x, right? Then we have set of data, that is n number of data. So then what we are doing, we are finding the sum of the square of the errors, right? So that's why this is our model, regression model. So alpha plus beta x I, okay. And we have taken the square of it, taken the difference and square of it. Okay. So now what we are doing, this is a function of alpha and beta. What concept you are applying in this case to find out the alpha and beta? So we have to minimize the error. And this is the function of alpha beta. So we have to do, what is that? We have to get the partial derivative and equate to 0. Two simultaneous equation will be coming in terms of alpha and beta. Then we'll be solving the simultaneous equations and we'll get alpha and beta. So that I'll be showing you. You can see. So I have differentiated with respect to alpha and beta. I got two simultaneous equations. Now one is dou q by dou alpha, because q is my function of alpha and beta. So I have equated to 0. And second one, because the function of two variables alpha and beta, then again I differentiated partially with respect to beta and equated to 0. Now I got two simultaneous equations in terms of alpha and beta. Okay. So then how they have designed the network. So first we'll solve these equations and get the alpha and beta, so that if you substitute in this equation after finding the alpha and beta, so this will be your model. Okay. So now what I'll be doing, I'm representing in the network structure. Just now I told how they have represented in the artificial neural network. Now you can see what I've done. Instead of writing y equals to alpha plus beta x, what I did, I wrote over here x into w and b, and this is 1. So now you can see w is your beta and b I have written alpha. Okay. Now, and f of theta, that activation function, what they are saying in the neural network, I took it as f of theta equals to theta. So whatever it comes will pass to the output. Okay. Our transfer function is same thing. Whatever it will give, same thing it will return. So then exactly what we have written, so that is the linear regressions. So they are saying about this artificial neural network. Now we'll see. I have taken one example, so we'll just calculate. Already I calculated. I'll show you how they will represent. Suppose we have the data and we have to design that neural network for it using this least square method. So in this case, suppose I'm getting summation of xi, that is coming, in this particular it is coming 154. Okay. And summation of yi, that is coming 483. Okay. Then summation of xi square, that is 3676. Then summation of xi yi, that comes 11010. And number of observations in this case is 7. So according to the means what we have discussed now, the simultaneous equation will be 7 alpha plus 154 beta, okay, is equals to, that is 483. Then next one is 154 alpha plus 3676 beta equals to, that is 11010. Solving these equations, okay, solving these equations. So we are getting alpha equals to, that is coming 39.67 and beta is coming 1.33. Okay, so then we can design our network. What is the network? So we can say like this, 39.67 and 1.33. So that's why we'll get it like this. Now, in this case, we can write over here that comes over here, the beta, that is W in this case, and that value is coming beta, that is 1.33. So this is your 1.33 and this value is coming 39.67. So 39.67. So that means whatever the values you will give over here, it will be multiplied with 1.33 and taking the summation of B. So this is called neuron because f of theta, we have taken activation function equals to f of theta equals to theta. So that's why whatever we have given, same answer it will be coming up. So it is asking for the 47. What will be the answer for it? So we'll just take the 47, okay, and multiply it and you will get the answer accordingly. So this is the way why I have shown this particular example. My aim is that what we have done before, they have included in the neural network. That means this is one kind of neural network they are representing and they are saying it is artificial neural network. But we have done before. Okay. So next we'll move on to the sigmoidal neural network. Then we'll see what kind of mathematics we are using there. Sigmoidal means, just now I have shown you we are using f of theta equals to theta. Now here they are saying sigmoidal function. There are different type of sigmoidal function is there. Means A-shaped means we will be saying as a sigmoidal functions. Okay, so there are different sigmoidal functions, but I have taken this particular sigmoidal function 1 by 1 plus e to the power minus theta. Then I'll take some what is that? We'll take data and we'll find out the W and B. So what is the concept behind it? That back propagation technique they are applying to get it. Previous example we have seen. Previous example they are applying what is that? Least square method, and this one what they are applying we'll see. Now this is our activation functions, sigmoidal function, that this is S-shape, right? There are different type of activation function. As per your requirement, we have to use it because already I told. So sometimes according to your distribution of data, you may not be able to fit the regression model. That already we have seen. But in case of neural network, there are different type of activation function, and you can make very complicated structure. So we can design. Okay, flexibility is there. So now what is the concept they're using? Again, it is totally mathematics. That is gradient descent method we are applying. That already you have done in your optimization technique. So what is the method we are saying? That gradient that gives you only a rate of maximum, right? So if you take the negative, then we'll be coming to minimum, right? So direction will be minimum. And this learning parameter we are using over here, what is that? That is the step size. So this method already you have learned. So what they are doing, suppose we have n number of data. So they will be finding again same thing, sum of the square of the errors, and they are taking the partial derivative with respect to W and B. Then this is the iteration method. Why? They are initializing the values of W0 and B0, something they're initializing. They don't know what is the values to be taken for W and B. So they have taken some values to these two. Then they found partial derivative with respect to W and B. Then they substitute the initial values and they update it. So then they will be calculating the new W and B. So they will they'll calculate the error. So this is the way they will be updating the weights. When this will be minimum, they will stop and they will say, this is our single neural network for the prediction of particular task, whatever you have, where you have collected the data. Okay. So then finding this W and B is not so easy task. Still the research is going on. If you search now, you'll find out the latest paper also showing basing on this gradient descent, because it's not an easy task to find the global minimum. So I'll show you what is the problem there. I have just written one MATLAB code, because you cannot find out manually in which way we have done linear regression, because how many iterations it will be taking, we don't know. We will be measuring error, and when error reaches as per the required error, like suppose we have taken 0.001, then we will stop it. So the same concept what I discussed over here. So I have written in the MATLAB code. Okay, so using this code, I'll find out the W and B. So now I have taken this particular example, right? The similar example I have taken, what we have done, because I wanted to compare the regression and what they are doing in the neural network. My aim is that one. And here also we are applying the concept of multivariable calculus. Okay, so now you can see we'll take X and Y values over here. Then each iteration I have calculated the change in weight and change in B. Okay, change in W and change in B. Then we have updated WB and also calculated mean square error. So you just see we are updating our W and B according to your this method, right? Already I told you this one. This is the formula we have used. Means W will be written. So accordingly we have got the values. Okay. So now you can see the last column, that is your mean square error. Now it is decreasing, you can see, and it is very slow. That gradient descent method is very slow, so it is decreasing. So now you can see at the end we stopped, because I have given the error stopping over here, suppose 0.010258. So that's why we can take these values 1.0736 and B equals to minus 0.32. So what you are finding, I'm just showing you how the error function. What is the error functions? Error function means already you have written, right? This error functions we can write like this. This is my error functions. That will be W and B. Okay, so that will be summations, and we are taking Y minus. This is the formula we'll be using, right? That is your neural network output, and that will be in terms of W and B. And you will be adding how many values are there? You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I equals to 1 to 10, and we'll take the square of it. How it will be calculated, that already we have discussed, right? How it will be calculated? It will be calculated like this. We have taken sigmoidal functions. So 1 plus e to the power minus W into X plus B. So that is the formula will be. So that means this X value will be taken 0.66, we'll substitute over 0.66 and we'll substitute over here. So that means that will be a function of WB, and Y is your corresponding 0.61. So this is the first one. Then we'll go for the second one. So because this is the first data, second data, like this, it will be taken. So in this way, we'll take the summation, and that function will be very complicated. If it is 10 data, you see how many terms will be coming up. Then we'll go for 100 data. So like this, I have shown the how its surface looks. Why my intention is, why I have shown this surface, because you should know how the surface looks, so that whether you are able to find out the optimum value or not, because this one is the optimum values. You can start from anywhere else. Gradient descent method means it gives the direction towards minimum. So that's why we can move. Suppose I started from here, it is, you can see I started with W equal to 1 and 1. See, W equals to 1 because it's a second iteration, means first iteration already it has been updated. But initially I started with W equals to 1 and B equals to 1. Okay, so now you can see I started from here itself. You can see I started from 1 and 1. Now the minimum is over here, right? So we are coming in this way towards minimum. Okay, so this is the minimum values. So that is 1.0736 and this is your B minus 0.32. Okay, so accordingly we'll get the values. So this is about error functions, but it is very slow, right? To get suppose 0.0001, so you think how many iteration we have to do it. Okay, so now I'll move on to the next one. So in this case, what we'll be doing, this is the values already we got it. W is equals to 1.0736. Okay, and B is your minus 0.32069. Okay, so in this way, you have to give the input and accordingly we'll get the output. So this is the way we'll be calculating and we'll get the error, right? Okay, so now what is the difficulties you will be facing in this case that I'm showing you? What they have done, now you mark these two things. Both the surfaces are same. The same surfaces I've taken. I use another algorithm, that is gradient descent, but though it is a very slow, I have taken very simple data. That's why we got 0.01, but sometimes you'll find out it takes 1000 also, it is not reaching 0.001 also. So what they have done, they have given one moment, right? Momentum method is there. So I applied that one. So that methods I applied here, no doubt it takes very less number of iteration. But what is happening, there is a chance to see, I'm coming nearer to the, I'll just, that's this one. You can see over here. What is happening? In this case, I'm showing you this particular diagram you can see. In this case, what is happening? I started from here itself and optimum value is over here, right? So according to the general gradient descent method, I'm coming to this point. Okay, but I took 300 something iteration for each over here. But in this case, momentum based gradient descent method, no doubt it takes very less. But what is happening after reaching nearer to the optimum values, though it's having momentum term, it is going away from it, again coming back to your optimum value. So that means why I'm saying, because still the work is going on this topic, because getting optimum values and because you cannot change the surface, that depends. So surface will be generated from the data itself, how data is there. So you don't have any control on data. Data can be anything. So what kind of surface is coming, whether you are able to reach or not, whether you are getting the W and B or not, that is a big thing for designing neural network. I'm just considering only single neuron and will be going for deep neural network. Okay. Now, these are the things already I discussed for your momentum based gradient descent, that already I told. Now the thing is, sometimes what is happening, if you already have whatever I have given, only third point I'll be discussing. Sometimes what is that, surface will look like in such a way that it will be oscillating. Okay, it will be oscillating. Oscillating means it will go that side, again it will come this side. So that picture I'll be showing you. If I move to next page, you can take this one. Now you can see this particular example. What is happening? So if you are taken the initial values over here, you will come this side, then you'll go that side. Again, you'll come this side. So you may not reach. You will be moving in this way due to the step size, due to the momentum based gradient descent. though it is having momentum. So that's why you are going, the step size will be increasing. Okay. So that is the disadvantage in your case of, you can say, that I have shown over here. Contour plot I have taken for that surface. Now you can see I've taken the contour plot of this particular surface. One kind of surface I've taken. Okay. So in this case, what is happening? So we are oscillating. We are not able to reach to the goal. So then how you are spending much time to get that values W and B. So that's why you have to work out, you have to develop the algorithm in such a way that so that you can reach the goal faster, right? Then everyone will apply your algorithm. Okay, so then nowadays, recently, generally deep neural network, everyone using RMS prop. So there are so many algorithms they are developing. Okay, these are the recent algorithms they have developed, and still that is not working 100%. Now I'll show you. In this particular surface I've taken, only the two variables. Now you think if I design, this is for only single neuron. We are talking of single neuron only. Single neuron with single input. So that's why there are two variables, W and B. Okay. Now in this case, what is happening? You see, I have taken four different algorithms. One is gradient descent, then momentum based gradient descent, then Nestrov gradient descent, and ADA-grad. So now you can see for reaching this error, what are the iteration they have taken? Gradient descent method, no doubt they are taking many iteration, 1762, and momentum based gradient method that 194. And in this case, we have taken 190 and 74 in this case. So that means you can work on this particular domain. You have to develop your own algorithm so that it will take very less iteration and you will get the solution for W and B. Okay. So this is about your error surface. Now you can think of different error surface and how to overcome, and we can get W and B very easily. Till now I have discussed for a single neuron with single input, and we have seen so many difficulties, so many disadvantages. So how to overcome, we have to think. Now we are going to design. Now you see, this is a artificial neural network. Now in this, I have shown the to find out what is that? How to find out the values of W and B for a single neuron with a single input. Now you see the structure of this neural network having m number of inputs and n number of outputs and three hidden layers. Three hidden layers means you can take any number of layers. Now in this case, these are the not neurons. These are not artificial neural network. Hidden layer onwards up to output layer. These are the neurons. Single neuron having, you can say this is one neuron with having summation, and this F is there, activation functions, and these are the inputs, right? These are the inputs. But in this case, again, one more area is there to do the research. Now what is happening when we'll increase the number of layers? How can you update the weights of this layer? You think this is the function of these weights. Again, this one is function of these weights, and this is the function of these weights, and this is the function of these weights. Okay. Now, if I have to update, how many partial derivative I have to add over here? I mean, multiply, applying the chain rule, this into this, this into this, this into this. Now, what is happening? Suppose your change in weights is coming. For this particular partial derivative, you have to multiply 4 times to update this one, 0.1. Then you multiply 0.1 4 times, 0.1 into 0.1 into 0.1 into 0.1. So it will be coming 0.0001. So if you are adding 0.0001 with the weight updation, then you are not able to change the weights because it is called vanishing gradient problem. So now we are facing vanishing gradient problem. That's a big problem and everyone is working on it. How to overcome that one. Okay, now whenever we are talking of deep neural network, what is deep neural network? Then this number of layer will be increasing. When we are dealing with the image, what is the number of inputs? Suppose now everyone is working on what is that? We are wearing the mask. Now the face recognition is very difficult now. Only the very small portion is visible nowadays. Now their camera is there at the gate, but they want to say whether that particular person is coming to inside that office or some other person. So it's a very difficult task. Previously, what was seeing the face, they are recognizing, and they, because there are so many features are there, so many characteristics are there. So basing on that, they are able to, what you can say, recognize whether that person or not. But nowadays, everyone is wearing the, you can say, mask, and that is a different type of mask. If suppose today I'm wearing one mask, tomorrow I'll be wearing another mask. So it is very difficult. Only the portion is coming your eye. So now they are working on it. What are the portion is visible? From that, how they will work so that they can recognize whether that person or a different person is entering into the office. So that is also working on. So when we are dealing with the image, now you can think, suppose we are using color image. If you change to numerical values, it will be coming 256 into 256 into 3, that RGB. So 3 layers. So now you can think what are the number of inputs. If that number of inputs and you are going to classify, so then you have to go for many number of hidden layers. If you are going for the many number of hidden layer, so deciding weights, just I have shown you the single neuron with single input, and we have seen what kind of surface is coming, and we may not be able to get the values of W and B. And you think this kind of work we are doing, then how you'll be doing? That's why the Google has developed an convolutional neural network. They are not showing this, how they are developing. Okay, how to overcome that vanishing gradient problem. They are not showing, they are not giving the idea about it. So that means you have to work on it, and we have to say how to update, because you may not be able to get these values of weights, because it's a very less number. If gradients is coming greater than 1, then it's a very large number will be coming up. So it won't be able to converge to the optimal solution. So it's a very big problem nowadays, and everyone is working on it. Okay, so we'll be coming to the image recognitions. Very simple. I'll move on to the next algorithm, that is over back propagations. Then I'll move on to another algorithm, and that is also fully based on mathematics. How it is, but if you see from outside, it won't be knowing how it is related to mathematics. Okay, that I'm going to show you. Now what I'm doing, you check over here. So okay, one is forward slash and one is backward slash. What is happening? How can you this slash, how can you represent? That will be 1 0, and this will be 0 and 1. Very simple. I'm not talking of that kind of image. I took very simple image so that we can understand, we can extend our work. 1 0 and 0 1. So what are the weights? Because I have represented the same neural network type structure, I want to decide the values of these weights, so that when we'll multiply and we'll have some threshold values, when greater than this will be the slash, and if it is less than, then this kind of slash. So that we have to find out again the weights of this filter. Okay, filter means we have to find out the weights. We'll just multiply, take the summation, and what is the greater than threshold values. If it is greater than that values, we'll say this one, and if it is less than values, we'll say this. Okay, so now we have to decide how to classify. So and sometimes what is happening, you may not get the actual data also. Suppose handwritten, na? So handwritten means somebody has given like this. So if you convert to numerical values, you may get like this also. So this is also forward slash. Means you cannot say this is not a backslash. So we have to say this is the same kind of slash. So how you will identify? How you will identify? So what I have done, I'm showing you the things how I have designed. See, I have taken different type of noise type also images I took. Okay. So for this particular slash, I have taken like this. Suppose somebody has written this kind of things and somebody has written very short this one also, and somebody has taken this way also, somebody has taken this way also. So I took different type of images because you have to train the neural network. You have to train in such a way that any kind of noise type image also there, so your system will identify. So for that point of view, I mixed some noise type images, and then I started working on it. So now you can see. So similarly, for this class, I have taken this kind of images. Okay. So then I changed to numerical. So this is my data now. So for this kind of you can see this is 1, sorry, 0. 0 means no color. 0, 1. This is 1, 0. Like this I have taken, and I represented in the numerical form. Okay, I represented in the numerical form. So these are the ones, and this is for 0. So there are two type of images. One this type of slash, another is this type of slash. So I have taken 1 and this one. Okay. So now you can see
design of neural network.
So then you see I have written, because how many things are there? I'll take W1, W2. See, W1, I'll took like this. This is your W1. So you should the same thing, W1, W2, and this is W3 and W4. And summation must be greater than equal to W0. So you should not get confused. This is the same thing because this is your bias. And if you add bias over here, then it will be greater than equal to 0. So if you keep bias that side, and that will be greater than equal to W0. So we are having W0, W1, W2, W3, W4. The same concept we are applying. Okay. Now you see. So then I have taken this one and one X1, X2, X3, X4. So then in this case, what I have written, what is the perceptron rule I designed? W into X greater than equal to 0 and W into X less than 0. Okay. So if it is dot product is greater than equal to 0, then it will be 1. So this category it will be coming up, and this. So how to find out the W? That is the main thing. Your work is how to find out the W. So that we have one perceptron algorithm. So we'll check how to find out this W. Now I'll show you. I have represented in the neural network. Again, I am coming back to single neuron. This is a single neuron. And instead of putting in this form, see, in this form, instead of putting in this form, I represented in the neural network structure, single neuron with, what is that? 4 inputs, because X1, X2, X3, X4, because 2 by 2 image, 2 by 2 image. And I have taken W1, W2, W3, and this is your W0. So now what this activation function I have taken like this, theta that is greater than equal to 0, it will be 1, and less than 0, it will be 0. That activation function I'm using. And this graphical presentation of this activation function we are using, because there we are using sigmoidal. Now I'm using this activation function. Okay. So then what is the how to calculate? Because there you have used a gradient descent method. In this case, what kind of algorithm we are using? How it is related to maths? That I am going to show you. Now you can see in this case what they are saying, this particular slash they are putting as a 1, and this kind of slash they are taking as a 0. So what they are saying, when error occurs, if X belongs to this and W into X must be greater than equal to 0 now, because it's a 1. So for 1, that must be greater than equal to 0. Though it is a less than 0, error is occur. So that W has to be updated. Initially, we have taken some values of without W now. So now W has to be updated. In this case, we are not applying gradient descent method. Now you can see over here. what we are doing, we are writing W equals to W plus X. If X belongs to this slash, then W into X greater than equal to 0, then we will be updating the weight in this way, W minus X. The question is coming, we go for this, how it is related to maths also. Okay, so that I am giving explanation in this case. Okay. Suppose we'll take, suppose we'll take, so suppose I'll take for that X is a vector, so that is belongs to P. X is a vector that is belongs to P. Then what does it mean? If W into X, okay, W into X that we have written, that is less than 0. Less than 0 means, what is the meaning of it? That means that is the angle between, that means angle between, suppose I have written alpha, between the vector X and the current W, right? What we have taken randomly. Okay, but what you want to do, and this angle is greater than, because less than 0 means it is greater than 90 degree. It is greater than 90 degree. Okay, what we want to make,
Voice is not audible, sir.
hello.
Sir, audible, sir.
Actually, due to power cut, my router will be switched off. Okay. So the router got switched off. So that's why the net is disconnected.
Okay, okay, sir. Okay.
So I connected through my mobile. So now it is working. Okay, now?
Okay, sir. You continue, sir.
Okay.
Okay.
Collaborator.
Okay, just to wait.
Spectrum learning algorithm. For X belongs to P.
Now it is visible, now?
Yeah, 100%. Did you say? Any meeting WebEx meeting.
Okay. So in this case, what we have to do, just you see, we want to make less than, that means angle must be, we want the angle must be, the angle alpha. Okay, the angle alpha must be less than 90 degree. So now this, according to this algorithm, whether we are able to minimize or not, we are able to making them greater, less than 90 degree or not, we have to check it. Okay. Now what I'm doing, I'll take, suppose the method is W new equals to W plus, that is X. They are applying this. So now what I'm doing, I'm writing cos alpha new. Okay. So cos alpha new belongs to, what is that? That will be W new W transpose X, because they are vector. W is also vector, X is also vector. So I have not taken divided by its magnitude. That's why I've written proportional to this. Okay. Now this we can write W plus X transpose into X. Then we can write W transpose into X plus X transpose into X. Okay. Now you see, what is the meaning of this? This one is cos alpha, right? Cos alpha plus X transpose into X. So this is a positive quantity. And now this cos alpha new is greater than, that means cos alpha. Why? Some term, positive term you have added over here. So we can write over here cos alpha new. Okay, cos alpha new is greater than cos alpha. Now alpha will be, what is that? Less than alpha new will be less than alpha. So that means by doing this updation, though it is a greater than 90, we are able to reduce the angle. So if you repeat these steps, you will find out the angle will be, what is that? Less than 90 degrees. So time will reach, we can come to that angle between, if they belongs to 1, so angle between them will be less than 90 degree. And if belongs to 0 or this class, if it is, then by using this concept, because same you just take the negative sign over here, then we can write cos alpha nu will be less than cos alpha and this alpha nu will be greater than. So in that way we can make 90 greater than, we can make angle between X and W greater than 90 degree. So this concept we are using. Okay, we are using this concept to update. So this is the technique. This is the concept we are using for perceptron learning algorithm, and that is related to your maths. Now we are updating next. Then question is that one theorem is there. Suppose by finite number of iteration, whether you are reaching, no doubt we are updating weights, we are able to reduce the angle between them, but whether you are will be reaching for all the inputs, it will be working or not. So one theorem is there. I'm not going to prove it. It will take time. So that through theorem also, using finite number of iteration, we can converge to the solutions. Why I'm showing, because you see the whole thing, because in computer science students, they are using this algorithm, but behind this algorithm, you have to go for the theorems, you have to go for the mathematics, then only we can understand how it works. So next we'll be going for, I have just used MATLAB code for finding the weights. What problem we have taken, we have to identify which one is the forward slash and which one is the backward slash. For identifying the slash, we have to go for the many iterations. So it is not possible to calculate manually in front of you. So I have written the MATLAB code, in which way I have shown the algorithm. That's this algorithm. Basing on this algorithm, I have written the code, and basing on that code, the answer is coming. The weights are coming. W0. This is the value of W0, W1, W2, W3, and W4. So these are the weights we found by using this algorithm, perceptron learning algorithm, and it is working. Now we can see, I'll go back to see, I've written this is the W and this is the X, and it is satisfying. Now I'll coming back to our image. Now this is my image. Now we can check over here also. Suppose if I take 1, 0, 0, 1. So that means this is the slash, right? This is the slash. So if you apply this one, it must be less than 0.19. This is W0, right? You can check over here also. 1 into minus 1.01. So it will be minus 1.01. Then 0 into 0, it will be 0. I'm not including. 0 into this one also 0, I'm not including. Then it is minus 1.37. So this value is less than 0.19. So this is the slash it is given. So you can take any values over there, right? So basing on that values, it will work. The thing is what I have shown you, how you will get these values. Now you can see, suppose the noise type also, if you take, whether it is giving you the values or not, we'll check. Noise type means if I take 1, 1, 1, and this is 0. So this kind of slash is there, right? This is over there. So whether you are able to get it or not, that also you can check. So it is coming under this one. Now I'll see this is noise type slash is there. So this means this image is like this. Okay, part of handwritten, the part of that slash is visible. So whether it is able to classify or not, that we have to check. Okay, now you can see I'm doing. Then it will be 1 into this. So that is minus 1.09, then plus 1.13, then minus 1.37. Again, it will be coming less than 0.19. Okay, because negative values is coming. So again, this slash is coming. So now you see how this particular filter, we are able to classify the noise type of images. Handwritten also slash we are able to classify. And the things in which way you have found that totally based on mathematics. Okay, so we can now you can think if it is a you can say 10 by 10 image. Here I have taken 2 by 2, 10 by 10. So immediately you have to increase the what you can say filter size accordingly, and you can get the threshold values. That will be the W0, and also we can classify. But that is a very difficult task because it's a big iteration, many iteration it is required to update your weights, and that we have to take care. Okay, so then we'll be moving on to convolution theorem. So convolution theorem, everybody knows, right? We are using in the Laplace transform, that is a continuous, and in discrete also we are doing. So what we are doing, just we have a set of values, just we are moving like slide, and we are taking the product and taking the summations, like f of u into g of t minus u. You are taking the product and taking the summations. Okay, so that kind of that everybody knows, but how you will be applying in your neural network, that I am going to show you. Okay, so this is totally everybody knows. I'm not going to use explain much about it. How the convolution theorem will be applying in our neural network. Okay, so now you see, I just modify, will increase things more, right? So in this case, I'm going to classify. Now I have taken 3 by 3. Okay, because that is 2 by 2. Very easily we get the values of W. But in this case, I'm going to explain about convolutional neural network. Okay, what is convolutional neural network? I'll explain through this concept. So what is this? Suppose that is a X, but in this case I will be taking the bipolar values. Suppose you want to take X. Now what is that? I'll take the values like this: 1, minus 1, 1. This is minus 1, 1, minus 1. Then it will be 1. Minus 1, 1. So that means 1 will be the white color and minus 1 will be the black color. So accordingly it will work, right? Accordingly it will work. So these weights I have calculated over here. Now you can see, suppose I will write O. So I'm just writing one minus 1.
Software engineering, class.
Minus 1.
This 1.
Minus 1. 1. Then this will be minus 1. 1. And it will be minus 1, right? Okay, so if you calculate over here how it is coming, just you multiply and take the summation. That means convolution means we'll put this filter on this, right? we'll put on this filter. See, now you can see I have to put like this. Are you getting my point? This filter has to put this way. So
3 to 4
now, if it is coming, what is the value is coming for it? That will be coming -4.
software engineering. MTech integrated course. MIS.
Okay, so in this case, it is coming. If I use this for a filter, it is coming -4. Now you can see -1 into 1, then 1 into -1, 1 into -1, -1 into 1. So it is coming -4. If you take the summation, product and summation, then move this filter. This filter I'll be keeping on this place, right? Now you calculate and take the summation. I'm using convolution theorem in this particular case. So it will be coming 4. Now you can check 1 into 1, then -1 to -1 plus 1, then -1 to -1, then 1 into 1. So it is coming over here 4 and -4. Similarly, we'll calculate this one. So it will be coming 4, then this is -4, then -4 and 4, right? So then what we'll be doing in this is called convolutional layer. Convolutional layer means we'll be putting this filter, and filter will work like product of will take the product element wise, then take the summation. That value will be written over here. Similarly, we'll put this filter on this because we are applying convolutional concept. That's why this layer named as convolution layer. Then pooling layer. Pooling layer means we'll be using some activation function. We'll decide what to be taken. Okay, so I'm taking over here is -1, then 1. 1. If it is greater than equal to 4, we'll be assigning 1. Otherwise, we'll write -1. Now I'm writing in this form -1, 1, 1 in -1. So I'm writing in this form instead of keeping in the 2 by 2 form. I have written in this form. Okay. Now if I go for next one, so it will be coming 1, -1, then -1, 1. So we can keep like this 1, -1. -1.
Nice presentation, 1. Good presentation, very useful and interesting.
Okay, so then we'll take this value. So what is it is coming? If you calculate, you just go on multiplying the values. Okay, go on multiplying the values and take the summations. So if you take the summations, okay.
Hello. Sir, any problem, sir?
Problem, problem.
No. So noise is coming. I think some noise is. Basa sir.
Okay, sir. Now it's okay, sir.
Yes.
Now it's
so
okay,
now
sir?
you just multiply. It's audible from my side.
Yes, sir. Audible. You can continue, sir.
No, some noise means some voice is coming. That's why I'm saying. Madam, can you make mute all?
Okay,
is it
sir.
possible?
Okay, sir. I'll do, sir.
Okay.
I think Basa sir unknowingly switched on the mic.
Harish Bashar, sir, please mute your mic, sir.
Basa sir. I'll
Sir,
just
no,
call.
No, it's not coming, sir. You can, I think you can continue, sir.
No, sir. Where voice is? Okay.
So, ma'am, is it okay?
Okay, sir.
I'm audible.
Now, okay, sir. Okay, sir. Continue.
Hello.
Hello?
No, I'm audible or not? Because you might have mute all. So mine is okay or not? That I'm asking.
Okay, sir. It is audible, sir. Audible.
Okay.
Okay.
Okay. So now you can see if I multiply 1 minute.
Hello. Sir, any
Yes,
problem,
madam.
sir?
Yes, madam. No. So due to park code, they said also I'm getting. Okay, now it's okay, madam.
Okay.
So then what we'll be doing, we'll multiply. So -1 into 1, then 1 into -1, 1 into -1, then -1 into -1. So it is coming -4. And if you multiply, so it gives you the value 0, right? So we'll move on to the next one. If I move on to the next one, you see the exact value is there, means negative. So minus, minus, plus, and all. So it will be 8 only. Now, if you move on to this one, so it is coming 1. This is 1. This is also -1. This is -1, and this is 1. So it will be 0. The first part is 0. So next one is -1, then minus, minus, minus. So it will be minus again. I think it is coming. Once again, I'll calculate 1, then -1, -1, +1. Okay. Next, if I calculate -1, -1, then -1, -1. So it is coming minus, this is 0 and it is -4. Okay. So similarly, you can calculate this one, right? Just all of you listen very carefully, then I'll explain. Let me calculate, then I can explain. So then if I multiply these things, so it will be coming -1, then it is -1, -1, and -1. Then it will be -1, +1, and +1, and it will be -1. So that means it is coming again -4. Now we are using here softmax activation functions, which is maximum it will return. So that means this is the O. Now you can see 1 is present in O form. You can see over here. This is O. So now if you want to do for, you can say, do for any other one also, it will be giving the answers. I'll show you next one. It will be showing you. Just wait, I'll do the next one, another examples, then we'll wind up, right? How it is working, I'm just, then I will explain. Explanation, I'm not yet started, I'm just showing you. So then if I am making the slash, okay, 1, 1, 1, and other one is I'm taking -1s, right? -1. Now, whether you are able to get this one or not. Now, if you go for this multiplications, it is coming, now you tell me 4, right? It is coming 4 because minus, minus, plus, so it will be coming 4. If you place this filter on this, because we are using convolutional layer concept. So if you put it over here, so it is coming -1, +1. Okay, then -4. So it is coming, I think, what is values is coming? -2 is coming. Is it okay? Again, I'll calculate -1, +1, 0. Then -1, minus, so -2 is coming. Okay, good. So next I'll place this filter on this one, right? So it will be coming, that is minus, then -2, and this will be 0, right? This will be 0. So it will be again -2. Then again you place the filter on this one. You have to place this filter on this one, right? If you place this filter on this one and go on multiplying and adding, so it comes 4, right? Because 1, 1, +1, +1, then 1. So 4 is coming. Similarly, you have to place this filter over here, then here, then here. The same operation we have to do it. If you do that operation, it comes -4. You can check over here also. Minus, then minus, then minus, and minus. -4 is coming. Then here it is coming 2. You can check 2. And this one is coming 2. And this one is coming -4. What pulling activation function we are using over here, I'll show you. That is, if greater than equal to 4, then we'll write 1, otherwise minus 1. So 1, minus 1, minus 1, 1 I have written. So for this one, what I have to write? Because none of them is 4. So I have to write minus 1, minus 1, minus 1 and minus 1. My activation function is what is that? In pooling layer, what kind of that if it is greater than equal to 4, it will be 1, otherwise minus 1. So that's why it is coming like this. Now you can see 1, minus 1, minus 1, 1, then minus 1, minus 1, minus 1, minus 1. So you go on multiplying. If you go on multiplying, now you can see exactly this is there, same weights. So here it will be 8. In other cases, you will get the less also. You can check. I'll show you the first one. It will be coming 1, then plus 1, plus 1, plus 1. Then 1, minus 1, minus 1, plus 1. So that means it is coming 4. Less than 8, you can see. The maximum will be this one, because this kind of slash we have taken. Now you move on to this one. So if you move on to this one, it is coming minus 1, minus 1, minus 1, minus 1. And this one is coming 1 into, it will be coming minus 1, plus 1, plus 1, and minus 1. So it will be again minus 4. And you move on to this one. This one means it is coming minus 1, plus 1, minus 1, plus 1. Okay, then this particular case, it is showing you that is 1, minus 1, minus 1, then 1. So it is 0. So it will be again, it is coming 4. Okay, so now which one is the maximum? 8. So this kind of slash is it. The thing is what I'm going to, so in this case, what we have to find out? We have to find out what is that? These values, sorry, this filter, how to know that because here I have taken the what you can say the weight values, but finding this value is not an easy task because I have taken only 4 characters and I'm going to classify them, and I have taken this kind of filter. Suppose if you go for a big image and that will be 256 by 256, you think what kind of filter will be using convolutional for the convolutional layer. So it will work because the Google has developed a convolutional neural network, but they are not showing this kind of how they have how they are getting these weights. They are giving, you can update these weights. This is a fully connected layer. Fully connected layer means it is a neural network, general neural network. But this is pooling layer and convolutional layer. Pooling layer means we have taken as a, if it is greater than equal to 4, then it will be 1, and less than 4, it will be minus 1. So that kind of convolutional layer and pooling layer, nobody is showing that technique. Whoever may be developing, because so many ResNet 50, ResNet 80, so many different network they are developing. Okay, so they are not showing how they are calculating, because if you are, it's not easy task to calculate, because you will face vanishing gradient method. So that's why it is not easy task to calculate this weight. But same method we are using gradient descent method, you have to develop these weights. But here I know the values I have written over here, and it is working very nicely. The thing is how to calculate these weights. That is the main thing. So in this case, I have demonstrated what is that? You can classify X, O, this slash and this kind of slash, so that these are the convolutional layer, and this is the pooling layer, and this is fully connected layer. Fully connected layer means it is just like your artificial neural network, but this is the different type of layers, right? You can extract the features. Suppose in face you have taken, you can extract eyes, you can extract mouth, you can extract so nose, so you can extract by using this convolutional layer and pooling layer. But it is not so easy task. It will be extracting the features of the image, but it is not easy task because of how to know that what kind of filter will be using and what kind of what is the size of the filter, because I have used 2 by 2 filter. How you will be knowing that what size, because it's a very 3 by 3 image I have taken. It's a very simple way we can calculate. But if you go for actual image, that is 256 into 256 into 3, that will be your color image. So it's very difficult task to do it. But we are using mathematics, that is convolution theorem. Okay, so this is about your convolutional neural network. Just general diagram I have shown over here. You see what kind of convolutional layer they're using, 64 into 64, 8. That means they have taken one convolutional layer, then extracting this kind of. Now you can see in my case, I have showing 2. In this case, it is 8 number of convolutional layer fitting. Now again, max pooling they have taken. Again, you see convolutional layer. So there are many convolutional layer and a pooling layer. Sometimes you're using maximum pooling, and sometimes you'll be taking average pooling. And these things nobody will be giving idea about it. They will be designing. Some of the tools is available. ResNet, Google Net. So many nets available in the your MATLAB and Python, but they won't be showing how they are calculating, how they are designing about this convolutional and pooling layer. But you have choice to update this one according to your data. You will be updating this fully connected layer, right? So one ResNet 50 they have designed. You see how it is working for classifying a image. The same, the different type of images, I mean, different type of network are there, convolutional network. I'm showing you just ResNet 50. You can see over there. See how they have written 7 by 7 convolutional layer over there, 64 and 3 by 3. Then again, so on counting, you will find out how many layers they have used up to this means convolutional layer and your pooling layer. Okay, only the last one is fully connected layer. They will be this, if you are using this tool, it is available in MATLAB and also Python, that is available. You want to use for your work, any kind of classification you are doing, you can use it. Only you can update this one. According to your data, you can update this data that already I've shown you. These values you can update. You see, these values you can update. Okay, so you can update this one, but you cannot change these values. You can use this ResNet 50 tool and we can do your work. Any kind of research work, if it is related to your image, you can go for this kind of network that is available, convolutional neural network, and you can use and you can classify your work. Okay, thank you.
Ajay, sir, CR came to me, sir. Actually, you have 7th last hour for EC B section. Today. By 3:10, CR came to me and he has given the information not came to the class. That's why I called. I was not in the class. I came. Okay, okay. By 3:10, CR came to me, sir. Yeah. Not represented. Okay. I came. Okay. After some time, he came. Okay, okay. Tried to call you. I tried so many times. You have not lifted. You are.
Hello.
Okay.
Madam, it's over, madam.
Any questions from the participants, sir?
No, sir. 45604. Last number. No, sir.
Hello. Any
Madam, it's over.
participants?
Hello, sir. This is Mardachalam from Coimbatore. So it is a very wonderful presentation, sir. It's an informative one. So I have a simple question, sir. So I have an image and with noise image. Can I use this convolutional neural network for removing that noise type of problems?
No. Noise I included for means you can design nice network, because see, if you don't add noise, intentionally I added the noise, because if you add the noise, suppose you are going to classify the handwritten letter. So if you don't add noise means what? You just write down handwritten and then convert to numerical matrix form, then you train the neural network.
Okay, sir. So there are several noises, spectral noise, Gaussian noise. So that type of filters we can use it in the
Yes.
Okay, sir. Thank you.
Means my means why I have added over there, because suppose you are going to design a new neural network to classify. So in those cases, as many images and different type of images you go on adding, so that you will design a better neural network. That is the thing. Suppose one kind of image you have not thought of it, but that has been given. So in that case, it may fail to classify. So for that point of view, as many you can give, it will be better. So accordingly, the weights will be updated.
Thank you, sir.
Any other participants? Okay, sir. Okay, thank you
Okay,
very
okay.
much, sir.
Thank you, ma'am.
Much for your elaborative description about the mathematics in this deep learning. So we have neatly explained about the artificial neuron, then about the artificial neural networks, and you explained with an example by writing a mathematical code, sorry, MATLAB code, and also the discussions we have nicely, sir. And about the architecture of artificial neural network and deep neural network, how the gradient descent method, and about the design of neural networks, convolution neural networks, all those things, sir. Very nicely presented, sir.
Thank you, ma'am. Thank you.
Thank you very much,
Madam,
sir.
should I leave because I have some work? I leave, madam.
Okay, sir. Okay, sir. Thank you, sir. Thank you very much, sir, for your nice presentation. I'm sure that all our participants have enjoyed your lecture, sir.
Thank you, ma'am.
Thank you, sir. You can leave, sir.
Okay.
Okay, sir. And I thank all the participants for maintaining silence throughout the session. Yes, sir. And I wish all have a nice day, and we will meet tomorrow.